In Chapter 6, which you just took a test on, the focus was on discrete random variables. These were situations like take a sample of 30 people and then count how many people are over 6 feet tall. These were discrete because the possible answer to that question, how many people, should just be whole numbers. Right? It doesn't make sense to have 5.13 people who are over 6 feet tall. In this chapter, we're going to look at situations like take a sample of 30 people again, but instead of counting how many people have a certain characteristic, we're going to be interested in things like their average height. And when we talk about average height, now the possible values can be any decimal. And because of that, these are now called continuous random variables. In Chapter 6, when we talk about distributions for discrete random variables, they were tables. Right? They were tables that listed all the possible values of x along with their probabilities. Because we're now talking about continuous random variables where the possible values can be any decimal, you can't just list out all decimals. There are just too many. So instead of using tables, distributions for continuous random variables are going to be curves. And these curves are called probability density curves. Along the x-axis are all the possible values of your x. And then the way probabilities work is the area under the curve represents the probability. For instance, if I'm interested in the probability of getting someone who is between 5 and 5.5 feet tall, you would find the area under the curve between 5 and 5.5. Whatever that area is the probability of getting someone who is between 5 and 5.5 feet tall. For those who know calculus, this is going to be the integral of this curve between 5 and 5.5. Second fact I need here is the area under the entire curve. So under the entire curve should be everything, and everything is 100%. So the area under the entire curve is 100%. As a decimal is going to be 1. In this chapter, we're going to focus on one special probability density curve, and that's this curve. This is a curve that we've seen before in Unit 1 when we talked about the empirical rule. Right, so let's remind ourselves what the empirical rule says. The lengths of episodes of TV shows on Netflix are normally distributed with a mean of 43 minutes and a standard deviation of 6 minutes. The empirical rule says put the mean in the middle, so 43, and then use the standard deviation to go up 3 times, so 43 plus the standard deviation, so 43 plus 6 is 49, plus 6 again is 55, plus 6 one more time is 61. Going the other way, 43 minus the standard deviation, so 43 minus 6 is 37, minus 6 again, 31, minus 6 one more time, 25. And the empirical rule says between 1 up, 1 down is 68% of your data. Between 2 up, 2 down is 95%. Between 3 up, 3 down is 99.7%. And then everything is 100%. And then we can answer questions like, what percent of Netflix shows are less than 49 minutes long? Okay, so that's 49 and to the left. And the way we can answer that is we can take 49 to the middle first. Okay, 49 to the middle should be half of 68, right? So 49 to the middle should be 34%. And then middle all the way to the left. Middle all the way to the left should be half of 100%. So middle all the way to the left is 50%. And then together, that's 84%. So 84% of Netflix shows are less than 49 minutes long. And that's going to be the last time we use the empirical rule. Because now I'm interested in questions like, what percent is less than 50 minutes? And that's a question that I can't answer with the empirical rule because 50 doesn't land exactly on one of these steps. To answer that new question, I need three ideas. The first idea is the standard normal distribution. So every normal distribution situation or every empirical rule situation is essentially the same picture. Like for us, literally it's the same picture because I cut and paste this picture on every single empirical rule question. The only difference is what numbers go at the bottom. In other words, what number you put in the middle, which is the mean, and what number you use to count up by and down by, which is a standard deviation. Standard normal distribution, the word standard here refers to using the simplest mean and the simplest standard deviation. So for standard, we're going to be using the simplest mean, which is 0, and the simplest standard deviation, which is 1. So for the standard normal distribution picture, put the mean in the middle, so 0 in the middle, and then count up. So 0 plus the standard deviation, so 0 plus 1 is 1, plus 1 again is 2, plus 1 again is 3. And then going the other way, 0 minus the standard deviation, so 0 minus 1 is negative 1, minus 1 again is negative 2, and minus 1 one more time is negative 3. All right, so that's the first idea. The second idea I need is I want to be able to translate this picture or this situation onto this picture. In other words, where exactly should this 50 go on the standard normal picture? So on the original picture, 50 is between 49 and 55, right? It's between 1 up and 2 up. On the standard normal picture, then, it should go between 1 up and 2 up, which is between this 1 and 2. But my question is, exactly where should it go? And to answer that question, we need the second idea, which is the z-score. So this we've seen before briefly in the first unit also. The z-score is going to count how many standard deviations or how many steps you are above or below the mean. And we had a formula for this, which I'll write right here. Okay, so this symbol, that's mu, that stands for the mean. At the bottom, that's a sigma, that stands for the standard deviation. Okay, so now let's use this formula on this situation. Okay, so I want to know exactly how many steps 50 is above or below the mean. Okay, so this 50 is my x. Minus the mean. The mean was 43. And then at the bottom, standard deviation was 6. So on my calculator, up top, 50 minus 43. On the bottom, 6. Rounded to 3 decimal places. This is 1.167. Right, so what this is telling me is that this 50 is exactly 1.167 steps above the mean, above the middle. Okay, in other words, it's exactly 1.167 standard deviations above the mean. Which means on this standard normal picture, it should go exactly right here at 1.167. Okay, which now brings me to the third idea. So on this picture, I want to know what percent is less than 50. So what percent is to the left of 50? which translated to the standard normal picture, I want to know what percent is to the left of 1.167. R will tell me that area, right? So if I have a Z, which I do, if I want the left area, which I do, then the command is pnorm, and R is going to do that for me. We're not going to do it right now, but these are commands in R that we'll need. And what R is really doing is it's calculating the area using the standard normal picture. So for those who care, you don't need to know this, but the equation for this curve is 1 over square root 2 pi e to the negative x squared over 2. Okay, that's the equation for this curve. And what R is really doing is it's finding the integral from negative infinity to 1.167. Okay, we're not going to do it using calculus. We're going to have R do that calculus for us. All right, let me summarize those 3 ideas that we just talked about. There's 2 main situations that you'll encounter in this section, actually in this entire chapter. X to area and area to x. For an x to area problem, you're going to do this in 2 steps. You're going to go from x to z first, and then from z to area. The x to z part represents starting off with the generic normal distribution picture. X to z is translating this generic picture onto this standard normal distribution picture. Okay, and you do that using the z-score formula. So this first step from x to z, you're going to do that using the z-score formula. Okay, from z to area, you're going to use R. Z to area. So if I have a z and I want the area, the command is going to be pnorm, and then feed it to z. The other situation you'll encounter is going in the other direction from area to x. And so you're just going to go backwards here. You're going to first go area to z, and then from z to x. Okay, the area to z part, you're going to do the backwards version of the R, pnorm here. So the backwards version of, or inverse version of pnorm is you're starting with the area and you want a z. You're going to do qnorm left area. So area to z, you're going to do qnorm. And you feed it to left area. And then from z to x, you're going to do the backwards version of the z-score formula. So I'm going to write it down here, and I'll explain to you where it comes from. So the backwards version from z to x is going to be mu plus z times the standard deviation. And this is really just the backwards or inverse version of the z-score formula. All you do is do algebra, get the x by itself. So multiply the sigma over, and then add the mu over, and then you'll get this equation. All right, so now let's try out some examples. Example 1. The amount of time customers spend waiting in line at a grocery store is normally distributed with a mean of 2.58 minutes and a standard deviation of 0.76 minutes. Find the probability that a randomly selected customer waits less than 4 minutes. First thing I'm going to do is I'm going to draw the normal distribution picture, and you really just only need to put the mean on the picture. So I'm going to put the mean in the middle. The mean here is 2.58. And then just as a note to myself, I want to kind of label what this 2.58 means, right? It's minutes. That's telling me that on the x-axis should be minutes. Now the second thing I need to do is decide whether this is an x to area or an area to x problem. Okay, and how do you decide? The question here is asking, find the probability. Okay, so I want probability as my final answer. Probability is an area. So whenever I say probability, you should think area. So probability, let me actually tell you. Area can refer to probability, percent, proportion. So all of those words, probability, percent, proportion, you should think area. So this is saying find the area that a randomly selected customer waits less than 4 minutes. So I want area as the final answer. This would have to be an X to area problem, right? Because you want to end up with an area as a final answer. So just tell me this is an X to area problem. And then I'm going to put the rest of the numbers on my picture here. Standard deviation, you don't have to put on your picture, so don't. I need to put the 4, though. So this 4 is 4 minutes, right? Minutes are on my x-axis. So this 4 is actually an x, right? 4 minutes. It's telling me that's an x. 4 should go over here, right? And then you have to decide whether this picture is shaded to the left, shaded to the right, or shaded in the middle. Okay, those are your 3 options in this chapter. It says weights less than 4. Less than 4 would be to the left of 4. So I'm looking for the area or the probability to the left of 4, right? And that's my picture. So making a good picture is important because it kind of tells you what answer you should expect, right? I know half the picture is 50%. So this picture is telling me that I expect my answer at the end to be more than 50%, right? So to be more than 0.5. We said it was X to area. This is telling me exactly what workflow I need to do. So first thing I need to do is a z-score. So z-score. X, we said what was the 4, minus the mean. Mean was 2.58. And then divided by the standard deviation, which is 0.76. Okay, so on my calculator, fraction up top, 4 minus 2.58. On the bottom, 0.76. Okay, round that to 3 decimal places. That's 1.868. Okay, so we just did the z-score. My workflow tells me that the next thing I need to do is p-norm. So p-norm to z. Okay, so in R, we're going to do p-norm 1.868. 0. Round this one to 3 decimal places also. 969. 0.969. Okay, and then you have to think. The way R works is you feed it a z and it spits out the left area. Okay, so this number that it spits out is a left area. And the question is, are you looking for a left area? Yes, you are, right? So this is shaded to the left, so I am looking for a left area. So that's exactly the answer I want. Example 2. The cholesterol levels for US adults are normally distributed with a mean of 201 and a standard deviation of 46. What cholesterol level separates the lowest 22%? Okay, so just like before, first thing I'm going to do is I'm going to draw the normal distribution picture and stick my mean in the middle. My mean here is 201. And then just to remind myself what this x-axis represents, let me label what 201 represents. 201 is a cholesterol level, right? So on my x-axis, these are cholesterol levels. And then the first big decision you need to make is this an X to area problem or is this an area to X problem? So there's 2 ways you can think about this one. This is saying what cholesterol level. So this one is looking for a cholesterol level as a final answer. And like we just discussed here, cholesterol levels are my x's on my x-axis. So this is saying that what x? What x separates the lowest 22%? So I want x as a final answer. This would have to be area to x. Another approach that would help you decide is, notice that I'm giving you this 22%. And we said percent, remember, is just another word for area. So I'm giving you an area to start. So the only situation where you're starting with an area is an area to x situation. So either way you think about it, example 2 is an area to x problem. Okay, and then let me draw the rest of my picture. So you need to decide whether this is shaded to left or shaded to right. Okay, and I need to put the 22% on my picture also. Standard deviation, you don't. So I want the x that separates the lowest 22%, right? So that 22% is an area. So I want the lowest, our lowest here is meaning the left side. I want the left area to be 22%. So I'm looking for the x that has a left area of 22%, which should be over here. Okay, and that's an area. So I'm going to label that up here. And I'm trying to find this missing x. I'm looking for the x that would have an area to the left of 0.22. And that's my setup. This workflow is telling me that first thing I need to do is Q norm, and then I need to do this equation. So first thing I need to do is Q norm. Now, Q norm, the way Q norm works is you feed it the left area of your picture. Okay? What is the left area of this picture? It's 0.22, right? So 0.22 refers to the shaded area, and that is a left area. So we're going to feed it 0.22. So Q norm 0.22. Okay, negative 0.772. And what is this negative 0.772? Well, we're going from area to z, so what Q norm spits out is a z. So this is a z of negative 0.772. Okay, and what I just did there was the Q norm part. Next step is to do this equation. So x equals the mean. Our mean here is 201 plus z, which is this negative 0.772, and then times the standard deviation, which was 46. Okay, so I'm going to type that in exactly like I see it there on my Desmos. So 201 plus parentheses negative 0.772, 46. 165.488. Okay, and then check my picture. I'm expecting an x that's to the left of 201. 165.488 is to the left of 201, so looks good. Example 3. A survey among freshmen at a certain university revealed that the number of hours spent studying the week before final exams was normally distributed with mean 25 and standard deviation 7. What proportion of students studied more than 40 hours? First thing I'm going to do is draw the picture and put the mean in the middle. Our mean here was 25. And then just to remind myself, what is this 25? 25 what? 25, these are hours spent studying, so these are hours. And then the next big decision you need to make is this an x to area or an area to x? Okay, notice that it says what proportion. So I want proportion as the final answer, and proportion we said was an area. Okay, so I want area as a final answer. This would have to be an x to area problem. Okay, let me put the rest of the numbers on my picture. Standard deviation, I don't need to put on there. 40, I do need to put on there. So 40 is hours, right? Hours are my x's. So this is actually my x. 40 goes right here. Question is this shaded to left, shaded to right, or shaded in the middle? It says more than 40. More than 40 would be to the right. So this is shaded to the right. And that's the setup. So I'm looking for the area to the right of 40. And then we said it was an x to area problem, so my workflow should be z-score and then p-norm. So z-score first. X, we said was the 40, minus the mean, was 25, divided by the standard deviation, which was 7. Okay, so on my calculator, fraction on top, 40 minus 25. On the bottom, 7. Okay, rounded to 3 decimal places, this is 2.143. Right, so we just did the z-score part. Next step will be p-norm it. So we're going to p-norm 2.143. Right, so p-norm 2.143. Rounded to 3 decimal places, this is 0.984. Okay, is that my answer? Based on my picture, it doesn't look like my answer, right? It looks like a small area here, but I'm getting 98%, right? So that can't be my answer. And the reason is p-norm, that p-norm part is always going to spit out a left area, okay? So this is actually a left area. And the question is, do I want a left area? No, right? I want a right area. So this 0.984 refers to this unshaded part to the left. To get the other side, the shaded part, you just do 1 minus that, okay? So I have to do a 1 minus to get the area to the right. So my final answer here is going to be 1 minus 0.984, 0.016. Okay, that fits my picture better because it's a small area. Okay, so let's take a step back here and let's compare example 1 with example 3. So notice that here I didn't have to do 1 minus because that's a left area. P-norm always spits out the left area. But in example 1, I was looking for a left area. So I didn't have to do a 1 minus on example 1. Example 3, right? P-norm spits out a left area, but I'm not looking for a left area in this example. I'm looking for a right area. So I have to do a 1 minus to get the other side. Example 4. Men's heights are normally distributed with a mean of 68.6 inches and standard deviation 2.8 inches. Find the height that separates the tallest 3% of men. Draw my picture. Put the mean in the middle, 68.6. And then to remind myself what this x-axis stands for, it's inches, or height. And then decide whether this is x to area or area to x. So I noticed that I'm given this percent. Right, percent, you should think area. So we're given an area. So this is telling me that I'm starting off in an area, so it would have to be an area to x. Okay, so this is an area to x for sure. Another way you can think about it is it's looking for height as a final answer, right? Height, we said, was inches at our bottom, our x-axis here. So this is looking for height as a final answer, which is also telling me that this is area to x because I want x at the end. Now, draw the rest of my picture. Okay, so I need to put this 3% on my picture. Standard deviation you don't have to put in your picture, but I do want to put this percent on my picture. Percent tallest, 3%, right? Tallest as in largest. This is actually an area to the right, right? Because tallest will be over on this side. So this is telling me that the area to the right is 3%. Okay, always convert percents to decimals. So this is actually 0.03. Okay, move decimal 2 to the left, you get 0.03. And then I'm looking for this x that has an area of 0.03 to the right. And then I think I'm ready now to do my workflow. So the workflow is I need a Q norm, left area, and then do this formula. So first thing I need to do is Q norm. Now, notice it says Q norm left area. So I need a Q norm and feed it the left area of my picture. Is 0.03 the left area? No, right? 0.03 is this shaded part, which is the right area. So I need to actually find this unshaded left area to feed into my Q norm. So how do I find this unshaded part? Okay, so anytime you have one side and you want the other side, you do 1 minus. So I'm going to 1 minus that 0.03. 1 minus 0.03 is 0.97. So 0.97 is the unshaded left area that I need to feed into R. So we're going to feed into R 0.97. Not 0.03, right? Because 0.03 is the right area. The way Q norm works is you always feed it the left area. So Q norm 0.97. Oops. I need to do that in R. Round to 3 decimal places, this is 1.881. Okay, so that's actually a Z, right? So we're going from area to Z. So this is my Z. 1.881. And then finally, last step, go from Z to X using this formula for X. So X equals the mean, 68.6, plus the Z, which is 1.881, times the standard deviation, 2.8. Okay, then my final answer, $68.6 plus 1.881, 2.8. 73.867. Okay, I was expecting some x that's to the right of my 68.6, right? 73.867 is to the right. Looks good. All right, before we move on, let me back up a bit and point out something. In examples 3 and 4 that we just did, both of these pictures were shaded to the right. Because of the way P norm and Q norm work, so P norm only outputs the left area and Q norm only takes the left area. So anytime you have a picture that's shaded to the right, you will have to do a 1 minus at some point. And the question is, where do you do the 1 minus? You always do the 1 minus on the area. So in an x to area situation, the area is at the end. So you need to do the 1 minus at the end, which is what we did, 1 minus at the end. In an area to x situation, right, you're starting off with the area at the beginning. So you need to do the 1 minus at the beginning, which is also what we did, right? We did a 1 minus at the beginning in order to plug into Q norm. So that's just a little tip for when you do the 1 minus. Back to example 5. A soda machine dispenses into 12-ounce cups. Tests show that the actual amount of soda dispensed is normally distributed with mean 11.5 ounces and standard deviation 0.21 ounces. What percent of cups will receive between 11.2 and 11.45 ounces of soda? Okay, so same as before, I'm going to draw my picture with the mean in the middle. Our mean is 11.5. And then to remind myself, this 11.5 stands for the ounces. So ounces are on my x-axis. Okay, next thing I need to do is decide whether this is x to area or area to x. Notice that it says what percent. Okay, so I want percent as my final answer, which is an area. Okay, so if I want area as my final answer, this would have to be an x to area problem. Okay. Another way you can decide is I'm given 11.2 and 11.45 ounces, right? Ounces are my x's, or my x-axis here. So these are both my x's. So I'm given x's to start, so it's x to area. Okay, so to draw the rest of my picture, I need to put 11.2 and 11.45 on my picture. Standard deviation, you don't need to. So 11.2 and 11.45 are actually both on the left side here. So let me put both of them here. 11.2, 11.45. And I'm looking for the percent between those. So I'm looking for the area between those two. All right, so we said this was x to area. So my workflow is to do the z-score formula on both of these x's. So I'm gonna have two of these. First one for 11.2, so that's gonna be 11.2 minus the mean, which is 11.5, divided by the standard deviation, 0.21. So I'll do that one later. For the 11.45, it's going to be 11.45 minus the mean, 11.5, divided by the standard deviation, which is 0.21. All right, so on my calculator, I'm going to do both of these. The first one, 11.2, so fraction 11.2 minus 11.5 over 0.21. It's negative 1.429. Okay, for the other one, fraction 11.45 minus 11.5 on top over 0.21, negative 0.238. Okay, so I just did the z-score formula for both of my x's. Next thing I need to do is p-norm those z's. I have two z's, so I need to do two p-norms. So p-norm negative 1.429, and then also p-norm negative 0.238. Okay, so the first one, p-norm negative 1.429, 0.077. Okay, that's rounded to 3 decimal places. The other p-norm, so p-norm negative 0.238, 0.406. Okay, so these are areas. Okay, 0.077 is the area to the left of the 11.2. 0.406 is the area to the left of 11.45. I'm looking for the area between, so what do you do? Right? If I just take 0.406, subtract 0.077, that should give me the area between. So I need to subtract. We're going to subtract bigger one minus a smaller one. So final answer is going to be 0.406 minus 0.077. .329. Okay, so let's summarize here. X to area for a situation where you're looking for area between, right? You'll have two x's. So you have two x's. You need to do the z-score twice. You'll get two z's. You need to do p-norm twice. You'll get two areas. To find the area between, you'll subtract those two areas. Example 6. Laptop batteries have a mean battery life of approximately 11.5 hours with a standard deviation of 4.37 hours. Between what two battery lifetimes do 81% of batteries fall between? Okay, draw my picture. Mean in the middle, 11.5. And to remind myself what this x-axis represents, these are hours, battery lives. And then deciding whether this is x to area or area to x. Okay, notice that I'm given this 81%. So I'm given an area. This would have to be an area to x. And then let's draw the rest of my picture. So I need to put this 81% on my picture. Okay, the standard deviation I don't have to put on my picture, but I do need to put the 81%. So this 81% is between, right? So this should be an area between, which is in the middle. Okay, 81% as a decimal is 0.81. So I have an area in the middle that's 0.81, and I'm looking for these two battery lifetimes, right, which are x's. Look for two x's that have an area of 0.81 in the middle. This is an area to x. My workflow tells me I need to do Q norm and then this x formula. So Q norm Q norm, you always have to feed it the left area. Okay, is 0.81 the left area? No, right? 0.81 is the area in the middle. I want the left area. So I want this unshaded part on the left side here. How do I find this unshaded part to the left? So if 0.81 is in the middle, I'm going to first do 1 minus 0.81. Okay, 1 minus 0.81 is 0.19. Shaded part is 0.81. When you do 1 minus, that gets you the unshaded part, so that's the left and the right side together, is 0.19. If I just want the left side, what do? So 0.19 is the left and right together. If I just want the left side, divided by 2. So 0.19 divided by 2. Okay, so 0.19 divided by 2, 0.095. Okay, so that's this left unshaded part, which is the left side of my picture that I need to feed into R. So 0.095. Okay, so Q norm in R, 0.095. All right, negative 1.311. So this is a Z now. Okay, so I expect two answers at the very end, right? I expect two X's as an answer, which means I need to have two Z's to use this formula on to get my two X's. So I need another Z. If negative 1.311 refers to the left one, what do you think the right one is? It's actually just going to be the positive answer. So negative 1.311 and also positive 1.311. Okay, that's my two Z's. And now I have my Z's. I'm going to use this X formula, X equation for both my Z's. And that should give me my two X's. So for the first one, the mean, which is 11.5, plus standard deviation, or I mean, plus Z, which is negative 1.311, times the standard deviation, 4.37. Okay, so my first x is going to be 11.5 plus parentheses negative 1.311, 4.37, 5.771. Okay, so that's one answer. The other answer, using the other z, the mean 11.5 plus z 1.311 times the standard deviation 4.37. And my second x is going to be 11.5 plus positive 1.311 times 4.37. 17.229. Okay, so that takes care of the three situations that you'll encounter. So example 5 and example 6, both of these were shaded in the middle. One of them was an x to area, and the other one was an area to x. Examples 3 and 4, both of these were shaded to the right. One of them was x to area, the other one was area to x. And then example 1 and 2, the picture for both of these were shaded to the left. One was an x to area, and the other one was an area to x. So that takes care of all the possible situations that you can encounter. Which brings me to example 7. Scores on a statistics final in a large class were normally distributed with a mean of 75 and a standard deviation of 8. Find the 85th percentile of exam scores. Let me draw my picture with the mean in the middle. Our mean here is 75. And then just to remind myself, this 75 means what? 75 is the scores, right? So my x's are the scores. Now, next question is this an x to area or an area to x? So I'm telling you, find the 85th percentile. What does 85th percentile mean? We talked about this in unit 1, right? 85th percentile means 85% of the data is below. So 85% below. So really, I'm looking for the exam score that has 85% of the data below it. I'm giving you 85% here, so I'm actually giving you percent. Percent is area, so I'm giving you the area. This would have to be a area to x problem. Because you're starting off with the area here. Question is this shaded to left, shaded to right, or shaded between? 85% below, right? That tells me it's to left. Anytime you have a percentile question, it's always going to be shaded to left. Okay, so I want 85% as an area. Okay, so I want 85% to left. Okay, where should it actually be? It doesn't actually matter that you draw the picture accurately, but let's try to be accurate here. So 75 is in the middle, right? Which means 50% is to the left. If I want 85% to the left, it would actually have to be somewhere over here to be 85%, right? So 0.85 is the area, and I'm actually looking for the exam score that has 0.85 to the left. We said this was area to x, so first thing I need to do is Q-norm the left area. So we're going to Q-norm what's the left area? Is 0.85 the left area? Yes, it is, right? So 0.85 is this shaded part, and that is the left area, so I don't need to do anything to it. Okay, and so we'll Q-norm left area. So Q-norm 0.85. .036. Okay, that's going to be a z. So our z here is 1.036. All right, we just did Q-norm. That takes us from area to z, from z to x. Do the x formula. So x equals the mean, which is 75, plus the z, which is 1.036, times the standard deviation, which is 8. Okay, so plug this into my Desmos. 75 plus, parentheses 1.036 times 8. 83.288. All right, that's it for today. I'll see you guys in the next one.